there any questions? Actually, while people are looking that up, I need to grab one more thing, because there's always something. All right, any questions?
I have one for plugins out on chapter 9.
Chapter 9.
That's 33 and 34. Like I understand
Is it
33.
33, 34?
Uh-huh.
All right.
But 34, when you calculate force of gravity on the same mass, do you plug that in for mass 2, the second one? The 6.4 times 10 to the 6?
No, all right, so you have the generic formula that the gravitational force, G, mass 1, mass 2, R squared. R is the center to center distance.
Okay.
So when it's on the Earth's surface,
The center of the Earth to the center of the mass?
yeah, so that's 6.4 times 10 to the 6th meters.
Yes.
So 33, and then the masses would be 1 kilogram, and then the mass of the Earth.
Okay.
In B, it is 6.4 times 10 to the 6 meters above the Earth's surface. So I know from here to the Earth's surface is 6.4 times 10 to the 6 meters. And now it is an additional.
So you multiply that by 2, or you put a 2 in front of
Yeah,
it?
so the R would be 12.8 times 10 to the 6th.
Oh, okay. So it would just be the first number, the 6.4 that you times, that would be doubled.
Yes.
So, and then it would still be times 10 to the 6th.
Yes.
Okay. And then 47 for think and rank. Pretend you fall into a hole bored completely through the earth.
Okay.
Rank your greatest place positions for speed and acceleration towards the Earth's center. So B would be the center.
Okay. All right, so if we think about what's going on there. I know that when I'm at the surface of the Earth, the gravitational force acting on me is my weight. If I am in the center, I am being pulled equally in every direction
By the Earth, okay.
by the Earth. So what would be the gravitational pull when I'm in the center?
0.
Okay. So when I'm going from here to here, it actually ends up being a linear relationship, assuming the Earth has a uniform density. So the biggest gravitational force is when I'm farther from the center.
Farther from the center versus when you're in the center. Okay. Okay.
Which is, and once I'm outside the Earth, then we have the 1 over R squared relationship. But if I'm inside the Earth, it's a directly proportional.
Okay, so like D would be the greatest.
D would have all right, so in terms of acceleration, that would be directly related to the force.
Uh-huh.
So D would have the greatest amount of force. A and C would the next, and B would have the least amount of force.
Okay, because it's in the center. Okay.
Yep. And so that would be the answer to part D, the acceleration, that order. Now speed, if I just step into this hole, my speed is close to 0 here. I'm going to get faster and faster and faster. I'm going to be going fastest at the center. I'll hit equilibrium,
At the
but
center.
I'm fastest at the center, and then I'll start slowing down again.
Why are you fastest at the center?
Because
Speed?
even though my acceleration is getting smaller as I go, as I get closer to the center,
Uh-huh.
I'm still accelerating until I get to the center.
Okay.
So I'm getting slowly faster and faster, because when I'm here, the net force is still towards the center in the direction I'm moving.
Okay.
So I'm gonna speed up. Once I pass the center and I'm now here, I'm still moving in this direction to start out with, but I'm being pulled back this way.
Because of the pull from.
Yeah. So I'm gonna start slowing down, and I'll slow down until I get to here. I'm gonna pop out on the other side, and so I'll be upside down. And then I will go back and do the same thing.
Okay.
And as we'll, I guess, address later on, this is actually, in an ideal case, simple harmonic motion.
Harmonic motion.
Harmonic, yes.
Okay.
It takes 42 minutes to get from here to here. And with a little bit of extra math, you could derive that in this class, but usually beyond the scope. So speed would be the greatest in the middle, then A and C would be the next greatest, and then D would be the slowest.
Okay, the smallest.
Other questions?
I think that was it for me.
Was it? Anyone else? All right, I want to mention that the 14 days, if you are inactive, that's the word they use, inactive for 14 days, on day 15, you will be dropped. I've been dragging my feet all semester long when that has happened. However, at this point, I've been basically given the right act. If you are inactive for 14 days in the class or in the lab, you will be dropped from both. So inactive means that you have submitted nothing online and you are not showing up to class. So if you are going to be absent, please just go in and do the weekly check-in, the weekly online assignment. That's enough. That is sufficient to show that you are still alive. But I think I've pushed the tolerance of administration to the breaking point. So if you do get dropped accidentally, let's say that you end up in a coma for 14 days, there's some form you can fill out, although we're running out of time for that. Form you can fill out to be reinstated. All right, in the absence of questions, let's do this thing.